Welcome to the second part of your lesson on the right triangle trigonometry. We will have the same targets as the first video, but for this time, we are going to determine the trigonometric values of angles using the coordinates of a point on their terminal side. Let's say we have an angle theta which is in standard position. This means that the initial side lies on the positive x-axis. We take a point on its terminal side. The coordinates of the points are 2, 3. Now we want to find the 6 trigonometric function values of theta. Would it be possible to do that? Well, previously we learned that the 6 trigonometric function values are ratios of the sides of the right triangle involved. But in this case, where do we determine the right triangle? Let's drop a vertical segment from point 2, 3 to the x-axis. Since that is a vertical segment, we are sure that it's going to be perpendicular to the x-axis. Thus, now we have a right triangle involving angle theta. We know that the vertical segment, which is also the opposite side of theta, measures 3 units, since the y-coordinate is 3, and the adjacent side of theta measures 2 units, since the x-coordinate is 2. Since we have the values for O and A, we now have to find the measure of the hypotenuse, or that is h. We know that this is a right triangle, so the Pythagorean theorem holds true. Thus, a squared plus o squared equals h squared. Notice that here, O is actually equal to the x-coordinate, and A is actually equal to the y-coordinate. Moreover, the hypotenuse is equal to the radius of the circle with center at the origin to the chosen point. Thus, we can write x squared plus y squared equals r squared. We then have 3 squared plus 2 squared equals h squared. This gives us h equals the square root of 13. Since we said that O is equal to y, A is equal to x, and h is equal to r, we are now slightly tweaking our formulas into notations with x, y, and r. Thus, sine theta becomes y over r, cosine theta becomes x over r, and tangent theta becomes y over x. Moreover, cosecant theta becomes r over y, secant theta becomes r over x, and cotangent theta becomes x over y. The notation difference is basically dependent on what is given. If a triangle with side lengths are given, then you have to use O, A, and H. If a point on the terminal side is given, then you use x, y, and r. As we previously noted, it always helps to write the values of A, O, and H before proceeding with our calculations. This time, to be consistent, we are using x, y, and r. So we write x equals 2, y equals 3, and r equals square root of 13. Let us obtain sine theta. Since sine theta is y over r, we simply have 3 over the square root of 13. We should rationalize this by multiplying the square root of 13 over the square root of 13, so it becomes 3 square root of 13 all over 13. Let's now have cosine theta. Since cosine theta is equal to x over r, we have 2 over square root of 13, or that is 2 square root of 13 over 13. Third, we have tangent theta, which is y over x, or that is 3 over 2. Let us also take the reciprocal functions of theta. First, the reciprocal of sine theta, which is cosecant theta. That is y over r now becoming r over y, so that is going to be square root of 13 over 3. For cosine theta, the reciprocal is secant theta, which will now be r over x, or the square root of 13 over 2. Lastly, we have cotangent theta, which will now be x over y, or 2 over 3. Let's now have some exercises involving these trigonometric functions. Let's find the 6 trigonometric functions of an acute angle theta if a point on its terminal side has coordinates -1 and 2. Since r isn't given, let's find r first. Again, we know that x squared plus y squared equals r squared by the Pythagorean theorem. Thus, -1 quantity squared plus 2 squared is equal to r squared. This becomes square root of 5 is equal to r. As we previously noted, it always helps to write the values of x, y, and r before proceeding with our calculations. So we write x equals -1, y equals +2, and r is equal to the square root of 5. Let us obtain sine theta. Since sine theta is y over r, we simply have 2 over the square root of 5. We should rationalize this by multiplying by square root of 5 over the square root of 5. So it becomes 2 square root of 5 all over 5. We proceed to solving for the value of cosine theta. Cosine theta is equal to x over r. Therefore, cosine theta is equal to negative 1 over the square root of 5. Or by rationalizing it, we obtain negative square root of 5 all over 5. Third, tangent theta is equal to y over x. Thus, tangent theta is equal to 2 over negative 1 or negative 2. Let us also take the reciprocal function values of theta. First, the reciprocal of sine theta, which is cosecant theta. Since sine theta is equal to y over r, then cosecant theta is equal to r over y. This becomes the square root of 5 over 2. Next, we have secant theta, which is r over x, so that will be the square root of 5 over negative 1, or that is negative square root of 5. Lastly, we have cotangent theta, which is x over y, and that will now be negative 1/2. Please always be careful with the signs because even if they are small things, they actually matter. So that's it. We have completed solving the trigonometric functions of an acute angle with a point on its terminal side. And that's the end of your second part of right triangle trigonometry video lessons. We never forget to thank the developers of the GeoGebra app which we use in drawing the illustrations in this video.